Hello friends, welcome to P for Physics Learn from Fun. Today we are going to do some very easy, basic and interesting numerical problems on interference. So let's start. Let's look at the first question and please pause and write it down, the question. Let's do it now. So what does the question say? The first wave is given by and the second one is this. Sorry. Yeah, so these are the two waves interfering, and the question is what is the resultant amplitude? This. So what is the formula here for resultant amplitude? It's a very easy one, given by a1 square plus a2 square plus 2a1 a2 cos phi. Okay, try to remember it as the resultant formula for vectors. It's actually same. So in this case the phi represents the phase difference between the two interfering waves. As we can see, we can write the second wave as 4 sin omega t minus kx plus pi by 2. Okay, so from these two equations we can say that phi equals to pi by 2, and you may not need to do it as well. If you only want to do it in short, if it is sine and cos, so it always have to be a 90-degree phase difference between the two waves. Okay, and as you can see in this question, a1 is 3, a2 is 4, phi is pi by 2. Just put it in the equation, you have your answer. So it should be 3 square plus 4 square plus 2 into 4 cos pi by 2. Cos pi by 2 is 0, so this whole thing disappears and the answer is 5. Okay, so it was easy. Let's look at the next question. So the next question says, in air the fringe width, which is written as beta, is 2 millimeters when the experiment is done in air, and when it is done in water, what should be the fringe width? So let's look at the formula for beta. It is lambda d by 2d, right? So now think, if we put this whole thing inside water, which one of these will change? The distance between the slit and the screen, the distance between the slits, or the wavelength? Obviously the wavelength, because these two are unchanged. So we need to see the relation between beta and wavelength only, which is beta is directly proportional to lambda. And now what happens to lambda when we put it inside any other medium except for air? So we know that lambda dash is given by lambda by mu, where mu is the refractive index of that medium. So since beta is proportional to lambda, we can write beta dash equals to beta by mu, and that's it. Just put the values and you will be. And what is the refractive index of water? It's 4 by 3. So 4 goes here, 3 goes here, 3 by 2, that is 1.5 millimeter. It should be your answer. Okay, so it was again another easy one. Let's do the next one. Oh, it's one of those classic very easy types. It says ratio of intensity, that is I1 by I2, is beta. We have to find I max minus I min divided by I max plus I min. So this is actually a basic one. Let's do it step by step. So as we know, intensity is proportional to a square. A is the amplitude. We have to find a1 by a2 from this one, which should be root of this one, so it should be beta or beta by 1. Okay, and a max by a min would be simply a1 plus a2, a1 minus a2. So root beta plus 1 by root beta minus 1. Simple. Now I max by I min, it should be square of this thing. Okay, so simply square it. So far it's simple. Now we have to do this componendo and dividendo. So, and don't actually leave it here. We can see we can put it in a better form. So it is a plus b whole square minus a minus b whole square. So it's 4ab, 4 root b into 1, and this would be 2 into a square plus b square. So it should be 2, a square is beta plus b square is 1. So this thing, so ultimate answer should be 2 root beta by beta plus 1. Yeah, that's your answer. See, so it was pretty easy one. Okay, now let's move on to the next one. Let's look at the sum again. Okay, so this question says we have two wavelengths, lambda 1 equals to 480 nanometer, lambda 2 equals to 600 nanometer, and the question is the nth of one's maximum will coincide with the n plus 1th of the other's maximum. Okay, so let's try to understand this question with the help of diagram. So if I can draw the diagram, we should know that the central maxima of both the interference patterns would be coincide, because the central maxima is always maxima no matter what the wavelength is. Okay, now the idea is this: beta is proportional to lambda, as we saw in the last problem. So the one with the less wavelength will be a little less wide, and this one will be a little more wide. So if I can draw it like this, here I am just drawing it arbitrarily, I am not measuring the ratio of lambdas, so I draw it a little wider. Okay, so this is the picture. The idea is, as you can see, this one, the slits are little, the fringes are little bit less wide, and in this case the fringes are a little wider. So let's look where the fringes actually coincide here. Now if we can count, we can clearly see the one with the less wide fringes have a more number of fringes, and this has less number of fringes. So idea is the total distance from the central maxima is equal for both. Now imagine this: you have a fringes of fringe with beta, and you have n fringes, so the total distance would be n into beta. Now this n into beta for both the patterns are equal. So we can say that n into beta is constant. Now as we can see that beta is proportional to lambda, we can also say n1 n lambda equals to constant, which means n1 lambda 1 equals to n2 lambda 2. Yeah. Now you should remember the whatever lambda is less will have n greater. That means 480 nanometer will have n plus 1 fringes as opposed to 600 nanometer which will have n fringes as in the question. So it should become n plus 1 into 480 equals to n into 600, and we solve and we are done. N equals to 4. Yeah, so we can say fourth maxima for this one 600 nanometer will coincide with the 4 plus 1 which is fifth maxima of this one 480 nanometer, and that's how we do it. Let's look at the next question which uses the same concept. It gives us two wavelengths. We have to find the ratio of maximas which coincide, and you know what, I'll let you do it because it's pretty much the same. So let's move on to the next one. It also gives us two wavelengths. One is 400 nanometer, another is 600 nanometer. It says when we use this one we have 12 fringes, when we use this one I don't know how many fringes. We have to find out how many fringes. So that's the question. So what is the idea? The idea is the total area in the screen is constant. Say you have n number of fringes, each of with beta. So what is the total area covered by the fringes? That would be simply n into beta, which is the width of the screen. So you can, if you change the beta, obviously the number of fringes will change, but the total distance or the total area of the screen would not change. So simply n into beta is constant, and as we know only the wavelength matters. Beta is proportional to lambda. It should be n into lambda constant, which should be n1 lambda 1 equals to n2 lambda 2, and we have n2 equals to n1 lambda 1 and lambda 2. So let's put the values. 12 into 400, 600. And it should be our answer. So you can do it like this, or you can calculate in your mind like this, the way I like to do. Whenever I see this one, I know that simply the whole of the beta won't matter. I need only lambda, and the total distance is constant, so n into lambda constant. That is in my mind. Now I see from 400 to 600 you have to multiply it by 1.5. okay, and if we change this equation, it goes n rises 1 by lambda. So if we multiply this by 1.5, we have to obviously divide the n by 1.5. So what I simply do, n2 equals to, we have 12 fringes divided by 1.5, and we will get 8 fringes, which is our answer. So this is another way to calculate in your mind. Okay, try to practice this, calculate in your mind, don't write it down or anything. Okay, it will help. So let's look at the next one. So it says about the fringe shift. when we introduce a transparent plate in front of one source. So it says that when the plate is 4.8 micron thick, that is when T equals to this thing, the number of fringe shift, which is denoted by M, it is 30. Okay, so let's call it T1, let's call it M1. Yeah. So what should be the width of the plate, that is T2 equals to question mark, when number of fringes shifted will be 20? That is the question. Okay, and also given that the refractive index of plate is 1.5. It may be needed, may not, let's see. So what is the formula for fringe shift? It is, if m number of fringes are shifted, then it is given by m lambda equals to T into mu minus 1. Okay, so let's see. As we can see, in this case we only need to find the relation between m and t, because the mu doesn't really change, so we may not need it. So if we take a look at m and t, we can say that m is proportional to t. Okay, so we can write m by t equals to constant, which gives m1 by t1 equals to m2 by t2, and if we can put the values, 30 by 4.8 equals to 20 by t2, t2 will be 3.2 micrometer is our answer. That's it. It was rather easy. It may not seem like, but it was. Let's do the next one. So in this problem we see the separation between the slits, that is 2D equals to 3 millimeters. The screen is at 2 meters away, that is capital D equals to 2 meters, and wavelength is 480 nanometer. Okay, and we have to find the distance between 8th bright to the 3rd dark. So there is one way to do it. You have to put the formula for bright, xn equals to n lambda d by 2d, and then for dark, this is for bright. For dark it should be xn equals to n plus 1 by 2 lambda d by 2d. This is for dark. What you can do for 8 bright, you can put in place of n, you can write 8, you will get this one. Then for the 3rd dark, you have to write n equals to 2. That's the trick, and you find both, then you simply minus. So that's one way to do it, and I don't like to do it in that way. I'll do it in some other way. I'll show. Let's draw the interference pattern first. Let's name them. The maximas, this is 1, 0, central maxima 1, 2, 3, 4, 5, 6, 7, 8. 8th bright, yeah. And we need first dark, second, third, fourth. More we don't need. So we need to find the distance between the 3rd dark, these two here, where it's bright. Okay. So let's count the number of fringes which is inside this area. We have 1, 2, 3, 4, 5, and the next one is not total, full fringe. We have only half the fringe. So we have a total of 5.5 fringes. 5.5 fringes. And if each of the fringe is beta wide, that is fringe width is given by beta, so the total distance would be 5.5 into beta. Let's call it x, this, and this is all we need to find. Okay, now put the formula for beta, which is lambda d by 2d, put the values and your work will be done. Let's do it. Let's convert these. it should be 480 into 10 to the power minus 9 meter, and this will be 3 into 10 to the power minus 3 meter. This is already in meter, we don't need to convert. So 480 into 10 to the power minus 9 into 2 divided by 2d, that is 3 into 10 to the power minus 3. Now let's do the calculation. 6, this is 160. So we have 2 into 55, that is 110 into, this is 16, and we have 10 to the power minus 6 here. So this one, it will get 10 to the power minus 5. Okay, this much meter. 11 into 16, 176 into 10 to the power minus 5 meter. So that's our answer. Let's put it in a better form. Let's take it to millimeter. We need 10 to the power minus 3, so it should be 1.76, yeah, into 10 to the power minus 3 millimeter, which means 1.76 millimeter. It should be our answer. Done. So that's how we do it. And if you do it, the first idea that I told you, that would have been much harder and much lengthier process. This is actually faster, and if you use calculator, it will come out even faster. So let's do it this way. So that's it for today. Next time we'll learn some more. Till then, keep practicing and share this video for others to see.